In this problem, we need to find all positive real numbers x that satisfy the following equation. And by square brackets, we denote a function of taking a lower integer part of a real number x. And by braces, we denote the fractional part of the real number x, which is, by definition, just the difference between x itself and its lower integer part. For example, a lower integer part of 4.2 equals 4. A lower integer part of 4.7 is equal to 4, and a lower integer part of 4 equals 4 itself. A fractional part of 4.2 is equal to 0.2. A fractional part of 4.7 equals 0.7, and a fractional part of 4 equals 0. Now we can use the definition of a fractional part of real number x that is given to us. So fractional part of a number x is the difference between x itself and its lower integer part. We can express x from here, so x is just the sum of its lower integer part and its fractional part. Now we can denote a lower integer part by n and a fractional part by alpha. So n here corresponds to a lower integer part and alpha corresponds to fractional parts of x. So in the task, we're asked to find all positive real numbers. So x is greater than 0, which means that n is a natural number or 0, and our alpha is a real number from the open interval. So alpha is from the open interval from 0 to 1. So now we know how to rewrite our 1 over lower integer part of x, 1 divided by 6 multiplied by a fractional part of x, but we don't know how to rewrite this term. So let's try to express lower integer part of 2x. So lower integer part of 2x equals the lower integer part of 2 multiplied by a sum of n and alpha equals a lower integer part of a sum of 2n and 2 alpha. 2n is integer, so this is equal to 2n plus lower integer part of 2 alpha equals 2n in case of alpha less than 1/2, or 2n plus 1 if our alpha is greater or equal than 0.5 and also is lower than 1. So we have two cases here. Let's focus on the first case. So our alpha is less than 1/2, which gives us that a lower integer part of 2x is equal to 2n. So this is our first case. And now we can convert our initial equation into 1 divided by n minus 1 divided by 2n equals 1 divided by 6 alpha. So 1 over 2n equals 1 over 6 alpha, which gives us that 6 multiplied by alpha is equal to 2 multiplied by n. So alpha is equal to n divided by 3. And we also know that alpha lies in the open interval from 0 to 1/2, and n is a natural number or 0. Okay, so now let's try different n's, and let's start from n equal to 0. So if n equals 0, then alpha is equal to 0 divided by 3. So it's just 0. And 0 is not in our interval, our open interval from 0 to 1/2, which means that this pair of numbers n and alpha is not suitable for us. Then let's try n equals 1, which gives us alpha equals to 1/3, which is greater than 0 and lower than 1/2. So now we have n, we have alpha, and we can find our x. So x is just the sum of n and alpha. So it's n plus 1/3, which is 4 divided by 3, and this is our first number. And if we take any n that is greater or equal than 2, then our alpha will be greater or equal than 2 divided by 3, which is greater than 1/2, which means that all such pairs of numbers n and alpha are not suitable for us. So in case when alpha is lower than 1/2, we can find only one x that satisfies our initial equation. Okay, but we have the second case. In our second case, alpha is greater or equal than 1/2 and is lower than 1. Consequently, our lower integer part of 2x equals 2n plus 1, which means that we can convert our initial equation into 1/n minus 1 divided by 2n plus 1 equals 1 divided by 6 alpha. So 2n plus 1 minus n divided by n multiplied by 2n plus 1 is equal to 1 divided by 6 alpha. Consequently, we have n plus 1 divided by 2n squared plus n is equal to 1/6 alpha. So 6 alpha equals 2n squared plus n divided by n plus 1. So now let's divide 2n squared plus n by n plus 1. So to get rid of this 2n squared, we need to multiply our n plus 1 by 2n, If we multiply our 2n by n plus 1, we will have 2n squared plus 2n. And if we subtract our 2n squared plus 2n from 2n squared plus n, we'll have minus n. And to get rid of this minus n, we have to multiply our n plus 1 by minus 1. If we multiply n plus 1 by minus 1, we will have minus n minus 1. And if we subtract it here, we'll have our remainder of 1. Which means that 6 alpha is equal to this 2n minus 1 plus our remainder 1 divided by n plus 2. 1 divided by n plus 1, sorry, n plus 1. Which means that alpha is equal to 1 over 6 multiplied by 2n minus 1 plus 1 over n plus 1. And this alpha has to be greater or equal than 1/2 and lower than 1. Okay, so now let's rewrite it in the form of inequalities. 1 over 6 multiplied by 2n minus 1 plus 1 over n plus 1 is greater or equal than 1/2 and is lower than 1. Let's multiply it by 6. So 3 is lower or equal than 2n minus 1 plus 1 divided by n plus 1, which is lower than 6. And now let's add 1, which gives us 4, that is lower or equal than 2n plus 1 over n plus 1, which is lower than 7. Let's try n equals 0. Then 2n plus 1 divided by n plus 1 equals 1. And 1 is lower than 4. So it means that it is outside our interval from 4 to 7, including 4. Which means that this pair of numbers, so this n and the corresponding alpha, are not suitable for us. Let's try n equals 1, then 2n plus 1 over n plus 1 equals 2 plus 1 over 2, which is equal to 2.5, and it is still lower than 4. So it's outside our interval from 4 to 7, including 4. So it's not suitable for us. Okay, but if n is equal to 2, then 2n plus 1 over n plus 1 is equal to 4 plus 1/3, which obviously is greater than 4 but lower than 7, so it's inside our interval. And we can find the corresponding alpha and then use it to find x. So the formula for alpha is right here. So alpha is 1 over 6 multiplied by 2 multiplied by n, and n is equal to 2, so it's 2 multiplied by 2, minus 1 plus 1 divided by n plus 1, so we have 2 plus 1 here, and this is equal to 9 plus 1 divided by 6 multiplied by 3, so it's 5 divided by 9. And the corresponding x is the sum of n and alpha, which gives us 2 plus 5 divided by 9. And this is equal to 23 divided by 9. And this is our second number. Okay, let's move further. N equals 3, which means that 2n plus 1 over n plus 1 is equal to 6 plus 1 over 4, which is obviously greater than 4 but lower than 7, so it's inside our interval. And we need to find alpha, which is 1 over 6 multiplied by 2 multiplied by n, so it's 2 multiplied by 3, minus 1 plus 1 divided by n plus 1, so 3 plus 1, which is equal to 21 divided by 6 multiplied by 4, so it's 7 divided by 8. And x is equal to 3 plus 7 divided by 8, which is equal to 31 divided by 8. So this is our next number. And if we take any n that is greater or equal than 4, then our 2n plus 1 over n plus 1 will be greater or equal than 8 plus 1 over 5. So it is obviously greater than 7. So any pair of such numbers is not suitable for us. Which means that the answer consists of 3 numbers: 4 divided by 3, 23 divided by 9, and 31 divided by 8.